All right, everyone. Welcome to the last day of ETH Seoul. Today we'll be doing 5 talks. First up, we have Starkware. Starkware will be doing a talk on volition, pushing the limits towards a cheaper L2.
Is this like moving? Okay. Hey everyone. I'm Ohad. I'm a product manager at Starkware for the last few years. Worked a lot on Starknet. And today I want to talk with you about volition and why it's a game-changing feature that would push the limits toward an even cheaper layer 2s. So first we're going to cover briefly what is Starknet and what it is. And then we'll dive right into volition, which is a feature that comes to Starknet soon. Basically discuss why it's a game changer and what's so novel about it. And then I'll end the talk with inviting you to see how you can use this feature with some examples. So Starknet is a permissionless validity rollup layer 2. It's launched on mainnet on November 2021. It's actually been the first general purpose ZK rollup to be on Ethereum mainnet. And since then, we've passed quite a long road. We see many attention from a lot of very talented developers. And today we have on Starknet a few hundred projects with more than 1,000 repositories in Cairo, which is a new language we invented for Starknet to be as efficient as possible, and more than $100 million invested in startups in the Starknet space. So really booming developer community, and we're already starting to see quite a lot of traction on our mainnet, with 13 million transactions and almost 1.5 million contracts deployed on mainnet to date. And you can see the vast diversity in our ecosystem. Basically, we have developers that are coming for DeFi. We have several dozens of projects, and for NFT and for gaming, and even for projects that are not usually used to be on L1, such as complex voting system, decentralized identity, really a wide variety. And the reason so many projects are keen to come to Starknet is basically due to the promise of a validity rollup, right? Because what do we do? How all of this magic work? We basically tell users, okay, you want to trade with scale, right? But also don't to give up on a term level of security. So users are doing a lot of work on Starknet, right? Basically, all the transactions are happening off-chain. And we then prove very succinctly and very efficiently that all of those transactions actually happened correctly. And this way, anyone that runs an Ethereum full node has, as one of its smart contracts, a Starknet verifier. Essentially, he verifies the entire Starknet transactions happened as they should be. This means that like if I have, say, 2,000 ETH and I move some ETH to one of you, then Ethereum doesn't need to know about it, right? All of Ethereum is doing is verifying a proof that indeed I signed the transaction, indeed I have the balance, and so on and so forth, right? So no one really can take my money. It's verified by Ethereum. And our proofs are really, really, really scaled, like 100 or 1,000x cheaper to verify than to execute. So this is how Starknet works. This is the promise, but something is missing here because you can quickly go to a site called L2 Fees that currently shows the fees on various L2 platforms and Ethereum, and Starknet is included here. And you can see that although that I claim that our proof generation is like 100,000x cheaper, de facto, currently we are 10x cheaper than Ethereum, and we are no different than any other layer 2 that is general purpose L2, for example, loop ring or not. So what's the gap here, right? Why we have such efficient proofs? So for example, you have your optimistic rollups that don't even have proofs at all. And the gap is only 10x and not much more. And the reason is that I, hidden some extra part that we pay, and actually we pay a lot on, and this is data availability. So it's not enough to pay, to say to Ethereum, look, Ohad sent this transfer, and this transfer is accurate. We need to also tell Ethereum, look, the new balance of Ohad is, now it's 1,000 ETH. Why do we do it, right? Why do we say with each and every proof that comes to Ethereum that basically all the new state? We do it because if you use Starknet, you want to assume only a Ethereum level of security, right? You don't want to assume that the Starknet sequencer would continue to work. You don't want to assume that the full node would continue to work, right? You want to say, okay, this is the Starknet state, and I'm fully aware of it, right? And I can work with it, and I can continue and advance my state on my own, right? So I can withdraw my money, right? Because if we prove that all the transactions are correct, but in the end I have their money and I cannot withdraw it because the sequencer is frozen, then it's not enough, right? We need to tell Ethereum basically all the data. And so, if we go from the other direction, if you don't know the data, it means that you essentially trust the sequencer to continue to be operating because if it would not, you don't know the data, you don't know how to advance the state, essentially your funds are stuck. It doesn't mean that someone can steal them, but they're still stuck. Not a very good situation to be in. Notice that with validity rollup, this is the sole role of data availability, just to ensure the system is not frozen. For optimistic rollups, it also has to do with the correctness. And data availability is damn expensive. As you probably know, it costs 16 gas to tell on Ethereum 1 byte, meaning that it costs a bit more than 500 gas to update Ethereum in a U256. Now, most use cases involve more than one U256 to report on, right? Even a simple transfer, my balance is updated, the recipient's balance is updated. Ethereum also needs to know not only the new balances, but like who is transferring to whom money, right? So it's multiple U256 to report on, right? So you can already see that even for the simplest of transactions, we pay thousands of gas for data availability. And currently on Starknet, data availability is more than 90% of the cost, right? The proof, like the things that people say, oh, it's complicated, it's less than 10%. So this is the current situation that we are in, right? We are like forced to tell Ethereum all of this data because we want to be secure, but still we pay heavy price for it. So I want to challenge those assumptions because like until now I said, okay, we must have data availability because what if the state is frozen? We'll need to know what it is, right? It's crucial to ensure all users have access to all of their possessions, but it might not only be the case, right? Let's see what different users would like to have. If we take that most trivial example, right? If we have very, very cheap NFTs, right? We want to have a game with NFTs that cost as low as 1 cent. It doesn't make sense currently to buy those NFTs not only on Starknet, but like on any layer too, because just to update on Ethereum, hey, look, there's been a transaction, I received a new NFT, it would cost much more than the cost of this NFT, right? So it's to be expected that users that want to buy one set NFT would say, you know what? I just want this NFT on the network. I'm okay with having a bit weaker security assumptions that like if some crisis happened, my NFT would be unavailable. I'm okay with that. I want my NFT and I want it cheap, right? And we can see a very similar phenomenon that can occur inside each and every transaction. Because let's assume I now buy an expensive NFT, right? I would like the information that I have this NFT to be backed by Ethereum. And probably the person that sold me this NFT would like its very much increased balance to also be backed by Ethereum data availability. But another thing that happens in each and every transaction is fee payments, right? I pay a few cents to the sequencer, potentially from like a small expenditure account with only a few dollars in it, right? That I expect will be able to fund many, many transactions going forward, right? And maybe I want to say, okay, I want the fee payment component to be processed much more cheaply. And I'm okay with losing $4 if some crises happen, right? Because on the bright side, I earn much, much cheaper transactions on each and every transaction. So there are many use cases where data availability on Ethereum might be an overkill, right? And might be a deterrent for the economical efficiency of the system. But I think that for some other use cases, and this is a really thing that was surprising to me, giving up on Ethereum-backed data availability actually makes no security compromise at all. For example, let's look on Oracle price reporting. Okay, I have an Oracle that updates the price of Bitcoin, and it does it, say, 3 times a second, right? And those updates are all independent of one another, right? In like few hundred milliseconds, a new update would come. If I go back to the motivation of why to have data availability, right, we say, okay, the state is frozen for a long time. Everyone would need to know what the state is. Assume we just lose access, right, to what the Oracle price reporting was. It doesn't really matter, right? We can tell this Oracle, okay, please let us know again the price, right, ideally, and we'll be good to go, right? There is no need to continuously pay in like high frequency in each and every transaction this extra cost of backing your data on Ethereum. And you can see similar thing that again happens in each and every transaction with nonce, right? Why would I need to tell Ethereum what the nonce of my account is? Does anyone care if its account nonce is like 1 or 200, as long as it doesn't have, a long series of transactions that is now seeing, okay, which are being like processed? So like with oracles, we can work with nonces that are not backed by Ethereum data availability, right? And we can progress them continuously, right, in ways that only Starknet know what the nonce is, right? And people can send transactions continuously on the network. And then, something bad happened, the entire database collapsed, we no longer have access to this data. We can always revert to a second track, right, of on-chain nonce. And now we can say, okay, we continue to send transactions to the network, but now we just use a second nonce. So to go back a second, right, we've seen why we need on-chain data availability, right, as a network. Obviously, it's crucial to have a Ethereum level of security when you're dealing with a large amount of funds or NFTs that worth a lot of money. But we also seen multiple reasoning for why this is an overkill, right? We've seen examples where making Ethereum-backed data availability doesn't make sense. Doesn't make sense from an economical standpoint, and we've seen cases where it actually doesn't help at all, right? And users are just paying for nothing. And one way to approach it is to say, let's make data availability cheaper, so it would be less of a burden across the board. And Ethereum obviously mines a layer 2 solution, so it's go forward with an EIP called 4844. Basically, what is Ethereum Improvement Proposal offers is to have additional data blobs that are attached to each and every block. And those data blobs will be only used for a data availability solution, and they're expected to be much, much cheaper. And the reason we want to do something better and are not satisfied with this solution are 2 points. First, it's unknown how much help it would actually be, right? Because if data availability becomes cheaper, suddenly you'll have much more layer 2 activity because it's cheaper, and then those blobs would fill up, and essentially you'll return to the same price. So like there is no inherent reduction fee here that we can count on in the long term. But I think the even stronger point is that you really want different levels of security for different actions you do on the network, right? If I now trade $1 billion, maybe you would say, okay, I'm not satisfied with these data blobs. I just want my data to be on the block as it is now. And if I trade 2 cents, then maybe even a 10x reduction that 4844 would maybe bring me is not enough. So we want to do something more flexible, and we'll introduce volition to Starknet within a few months. Basically, volition means that if you are now write smart contracts, you can decide what part of the smart contracts would be backed, counted on Starknet level of data availability got screwed. If you are using Starknet, but you always had Ethereum level data availability across your application, you are unaffected. So like HappyFlow, you can interact seamlessly with those parts that are like Starknet backed data availability. But if you want like evacuation that is not dependent on that, sure, go ahead, right? We don't hurt your security assumptions for trading $1 billion just because we added some features to those who trade cheap. So I'm going to dive even a bit deeper and explore with you exactly how it would work. Those are just 2 slides. I see what happens in this slide. Even the smallest thing, you can fully reconstruct this tree and can fully operate with it. And the left tree, we don't tell anything of what happens to Starknet to Ethereum, right? We basically just tell the root. And if you are now write smart contract, in the variable level, you can decide, okay, I want this variable to be in the right tree, and this variable to be in the left tree. So you have maximal flexibility, but also minimum impact, right? Because if this left tree is to go to west, right? Someone bad comes, throw it away. You can continue to work with this tree, right? You can continue to read and write variables from them. You can potentially continue to operate seamlessly. All of your code would still work, and you are totally unaware that like some data availability crisis happened to some other part of the network. So this is the design we have. Obviously, it puts more flexibility, but also more responsibility on the developers, right? Is it even make sense to use this design? How we envision things would work. So let's look at a concrete example, right? Like I call it the ERC20 of tomorrow. Because basically, if you think what ERC20 is all about, we really want this ERC20 to hold the large balances in as secure manner as possible, right? But if you're using this ERC20 to just transfer like a few cents, right, or a bit of fee, maybe it doesn't make sense to pay as much. So what happens basically, let's look on like hypothetical ERC20, say USDC on Starknet. So people from the outside can still call it the USDC contract, right? It has the transfer and balance off and all the methods we know and love. But internally, it does something very, very interesting. It's basically say, okay, I have a certain set of users and smart contracts and applications that want their data to be in the left tree, right? In the L2 backed data availability tree. And we have another set of users and applications that want their data to be as secure as possible, and they chose it to have in the L1 backed tree. And each and every user or smart contract can go to this USDC contract and tell him, look, I want my balance to be only available in the L2, or I want my balance to be available in Ethereum data availability. And when someone calls to this smart contract and tell him, I want to transfer funds, like with a sender and a receiver, the smart contract would say, okay, what is the data availability method of the guy that is about to send money, in this case off-chain, and what is the data availability method of the, in this example, contract that is to receive money, right? And this way it knows basically which variables to access, right? Which trees to update in a way that is corresponding to the transfer that is happening, right? But all the people outside this contract can be unaware, right? They can use this ERC20 with the same interface they are used to. They don't need to care about the fact that like actually much of the operations has become cheaper, right? Due to rational decisions that some of the users in the network made. And This is like the situation that would be in Starknet 0.13, as I just now presented it. Basically, we'll start with two trees. One is Ethereum-backed data availability, and the other that we currently plan to be like 10x cheaper when it comes to updating the data would be L2-backed data availability. Going forward, however, this spectrum should be much, much more refined, right? Because like Ethereum-backed data availability is the most costly and most secure option, and Starknet-only data availability is like the cheapest and the most insecure option, right? Because basically you gain it whatever data availability you choose. And going forward, we'll add more data availability methods. You can envision like a committee, right? Persons that say, okay, I don't want my data to be on Ethereum, but I still trust, say, Google to sign on my data. And if Google signs on my data, I feel it's good enough. I have it covered, right? And obviously getting signature from Google can be much cheaper than posting this data on Ethereum. Right? Other people could say, oh, we want Starknet to integrate with data availability solutions, right? Or other platforms that are there to storage stuff, or like Celestia, like Filecoin. So maybe we'll do some integration with them, right? To add basically people and developers more choice for where is the data that they care about in their application is stored versus how much it costs to use this solution. And if I'm allowed to zoom out a bit beyond just volition, I think that our approach here really reflects the Starknet approach. Namely, we want to allow developers as flexible choices as possible and to be as powerful as possible and see with much joy, if may I add, what are they doing with all this power. For example, account abstraction, which there is a full talk about it in like Vidal, but I just want to briefly touch on it, is another feature with similar spirit. Basically, we say no need for developers to always assume that like the nonce is incremental in a certain way. The signature verification is the same. We want to have account abstraction as a first-class citizen, right? We want to offer developers full flexibility how transactions are verified. What does it mean that the transaction is valid? What is the nonce management, and so on? And we had a hunch that adding this flexibility may be a good idea, and we have several things in mind, just like the RC20 I just presented. We have similar first naive ideas for account abstraction. But we couldn't have imagined that there would be projects and startups that take this concept and authenticate users with their fingerprints as a phone wallet, right? Which is something you just can't do on Ethereum today. So I'm excited because this is the new feature that would again pave the way to new frontier of flexibility from the developer side. And I want to see basically what you can do with all this flexibility and what trade-offs would you explore, and how can we help you to build the most scaled and secure application with Starknet. You can view here Tweet, Discord, and Docs. Thank you. Questions? Yes.
So first,
Hi.
sounds super cool. I guess maybe I didn't read the paper volition or anything, but it sounds like I'm struggling to see how it's not problematic when you have composability.
Mm-hmm.
For example, if there is a contract out there pre-existing that expects some sort of stake in another contract to always be available, and it doesn't know about volition, maybe it's an old contract, right? So I'm assuming that this is backward.
So first of all, it's backward compatible because if you don't state explicitly what you use, you're going to continue to use on-chain data availability. So that's a great question, right? You are right that, with composability, you also assume that the contract you're using works, right? So if you are using Ethereum-backed data availability and you, as a dependency, use another contract that isn't, then it's okay, everything would work. You just need to, be aware to whatever external calls you're making to external contract could break, right? So you need to carefully design everything. Our mindset is to encourage patterns that basically let users choose on each and every level, right? Do you want to use on-chain data availability? Do you want off-chain data availability, which is much cheaper, right? And then applications could be built in such a way, and even without liquidity fragmentation, right? Because it's the same contract, that basically allow users to choose. And thus users that would feel more comfortable would just have cheaper transactions.
I mean, if I'm like a very high stakes contract that already exists, there is another contract that I interact with and I depend on it that has upgradability. It upgrades to like a lower DA level, and suddenly that data is not available. And I am a contract that.
So you're correct, but if you're dependent on an external contract with upgradability, tons of things could break unrelated to this, right? You essentially trust their developers to always make mindful decisions, right, and always to not break anything, and this is no exception. Any other question? Okay, thanks.
All right, next up we have EtherFi. They'll be doing a talk on Ethereum solo stakers.
시작할까요? 네. 안녕하세요. Hopefully I can engage you by speaking in Korean. So yeah, give me some attention for your Korean friend. Thank you. 저희는 그 저는 이제 ETHFi에서 엔지니어로 있는 성윤이라고 하고요. 이렇게 이더리움 서울에서 발표를 하게 돼서 영광으로 생각하면서 편하게 이제 발표를 드리겠습니다. 이제 저희 ETHFi는 이제 탈중앙화된 스테이킹 프로토콜 서비스를 이제 제공하는 회사인데 리퀴드 스테이킹 데리버티브에 대해서 혹시 들어보신 분이 계시나요? 라켓풀이나 라이도? 네, 있으시죠? 감사합니다. 네, 저희는 이제 그런 프로토콜이랑은 다르게 이제 본인의 자금을 스테이킹 하실 때 그 자금의 출금 그리고 수익들을 출금 그리고 이 노드 운영을 중단한다던가 이런 것들에게 필요한 키를 모두 유지하실 수 있는, 그러면서 노드의 운영에 대한 권한만 노드 운영자들에게 위임하는 형태의 서비스를 이용하실 수 있도록 도움을 드리고 있습니다. 이제 이더리움 스테이킹에 대해서 이제 간단히 설명을 드리고 그 다음에 이제 조금 재밌는 칼고 컬츠 크립토라는 주제로 조금 얘기를 해보고 저 ETHFi에서 진행하고 있는 여러 가지 프로젝트들에 대해서 설명을 드리겠습니다. 우선 이제 이더리움 스테이킹은 이제 다들 아실 텐데 탈중앙화된 네트워크의 보안을 강화를 하는 대신에 그에 대한 리워드를 받는 행동을 말하고요. 근데 이제 스테이킹의 다양한 형태가 있는데 이제 가장 기본이 되는 이제 솔로 스테이킹부터 많이들 이용하신 이제 코인 거래소 등에 예치를 하셔서 이자를 받는 센트럴라이즈 스테이킹이 있고, 그리고 라이도와 같은 저희가 말하기를 유사 탈중앙화된 스테이킹 서비스들이 있습니다. 그래서 예상하실 수 있겠지만 저희들이 목표로 해서 나가는 방향은 디센트럴라이즈 스테이킹으로 탈중앙화된 서비스를 만드는 것을 이제 목표로 하고 있습니다. 우선 솔로 스테이킹 과정을 간단히 설명을 드려보면, 우선 스테이커 분들은 하나의 검증 노드를 생성하기 위해서는 32 이더리움을 필요로 합니다. 그리고 withdrawal 키와 validator 키라는 두 가지 키를 가지게 되시는데, withdrawal 키는 본인이 스테이킹한 자금에 대해서 수익이 발생했을 때 이를 출금할 수 있는 혹은 그 컨트랙이나 지갑에 대한 키를 말하고요. 그리고 validator 키는 검증 노드를 운영하는 것과 그리고 가장 중요하게 검증 노드를 엑시트하고 32 이더리움을 리펀드 받을 수 있는 데 필요한 키에 해당합니다. 그래서 이 두 개의 키와 32 이더리움을 가지고 스테이킹을 하시고, 그리고 이제 필요한 것은 검증 노드를 운영하기 위해서 하드웨어를 셋업하시고 소프트웨어와 환경 설정을 하시고 365일 24시간 이 노드가 원만하게 운영이 되도록 모니터링을 하셔야 되고요. 그래서 이제 당연한 장점으로는 본인의 자금과 노드 운영에 필요한 키를 모두 컨트롤하에 둘 수 있다는 장점이 있지만, 이런 기술적인 것에서 이제 디맨딩한 부분들이 있기 때문에 실질적으로는 많이 이용하시기가 힘든 부분들이 있습니다. 그래서 대부분의 분들이 가장 익숙하신 형태는 바이낸스나 업비트 같은 곳에서 제공하는 예치를 하고 스테이킹 이자를 받는 형태로 하는 중앙화된 스테이킹을 많이 이용하시는데요. 그래서 여기서는 어떤 일이 발생하는지를 보면 32 이더리움은 꼭 필요 없고 각자 원하는 분량만큼의 예치금만 예치를 하시면 됩니다. 그러면 이제 그렇게 불특정 다수에게서 모여진 32 이더리움들이 각각 하나의 검증 노드들을 생성하는 데 쓰이고요. 그렇지만 보시다시피 지금 두 개의 키, 빨간색과 보라색으로 나와 있는 키가 모두 다 지금 위임된 노드 운영자들 혹은 거래소 내에서 관리를 하게 됩니다. 그래서 이런 모델에서는 굉장히 프랙티컬하게 이제 간단한 솔루션이라고 볼 수 있지만 이 중앙화된 기관들이 처하는 어떤 규제나 기술적인 리스크에 함께 노출된다는 단점이 있습니다. 그래서 간단히 제가 업비트의 스테이킹 서비스의 이제 이용 약관을 한번 살펴보니까 이제 보시다시피 스테이킹된 디지털 애셋이 뭐 손실되거나 반환이 안 될 수도 있다. any reason으로. 그리고 두 번째 보시면은 서비스에 일시적인 제약이나 딜레이가 있을 수 있다. 어떤 이유로든. 그리고 회사는 여러 가지 이유들로 인해서 손실이 생겼을 때 이를 복구하거나 돌려줄 의무가 없다. 이런 이용 약관들을 명시하고 있습니다. 그래서 제가 말씀드리는 거는 뭐 퍼드를 퍼뜨리는 게 아니고 이용하시는 모델에 따라서 어떤 리스크가 존재한다는 것을 이해하시고 사용을 하시는 게 좋다고 말씀을 드리는 겁니다. 그다음 이제 라이도와 같은 반쯤 이제 혹은 유사 탈중앙 스테이킹 서비스들을 보면 이게 비슷한데 여기도 이제 32 이더리움 필요 없고요. 그래서 원하시는 만큼의 이더리움을 라이도 컨트랙을 통해서 예치를 하시는데 그러면 동일한 분량의 리퀴드 스테이킹 데리버티브 토큰이라고 하는 ST-ETH를 받게 됩니다. 이거는 이제 여러분들이 스테이킹한 이더리움에 대해서 그에 해당하는 원금과 발생한 스테이킹 이자를 돌려받을 수 있는 권리에 해당하는 토큰입니다. 근데 이것도 이제 스마트 컨트랙을 이용해서 이전에 이제 암호화폐 거래소에서 하던 형태가 스마트 컨트랙으로 넘어갔을 뿐 일부 중앙화된 노드 운영자들에 의해서 전체 시스템이 운영된다는 것은 동일하고요. 그리고 밸리데이터 키라는 게 모두 노드 운영자들에게 있기 때문에 여러분들이 예를 들면 뱅크런 같은 것들이 발생을 한다고 생각해 보면 모두가 내 이더리움을 돌려달라고 이제 아우성을 칠 때 밸리데이터 키가 없기 때문에 여러분들은 무작정 기다려야 되는 과정들이 생기게 됩니다. 그래서 이제 다음에 조금 더 재미있는 얘기로 들어가 보면은 혹시 리처드 파인만의 이제 카고 컬처라는 이야기를 들어보신 분이 계신가요? 이제 리처드 파인만이 본인의 이제 연설이나 이런 기고문에서 과학의 어떤 진실성, 인티그리티를 위해서 어떤 식으로 행동해야 되는가, 우리가 어떤 마음으로 리서치 임해야 되는지를 설명할 때 쓴 비유입니다. 이제 배경 설명을 좀 드리면은 이게 굉장히 재밌는 이야기인데 세계 2차 세계대전 당시에 미군들이 이렇게 태평양을 둘러싼 다양한 섬들에 본인들의 베이스 캠프를 두고 거기에 비행기를 경유지로 쓰고 카고 등 화물이나 이런 것들을 실어 나르는 용도로 사용을 했습니다. 물론 거기에는 그런 기술들을 한 번도 본 적 없는 이런 원주민들이 있었겠죠. 그래서 그런 사람들이 보기에는 하늘에서 이제 비행기가 내려오더니 미군들이 내리고 물자를 내리더니 거기서 음식들을 좀 나눠주고 이런 좋은 일들이 계속 있었던 거죠. 그러다가 이제 2차 세계대전이 끝나고 군인들이 이제 돌아가고 난 후에 어떤 일이 생겼을까요? 그러고 나서 이제 섬들을 가봤더니 굉장히 이상한 것들이 발달되어 있습니다. 그래서 이 원주민들 입장에서는 비행기 형태를 한 것들이 와서 나에게 좋은 맛있는 음식들을 주고 갔는데 왜 이 사람들이 더 이상 오지 않는 걸까? 이런 고민을 하게 되면서 일종의 컬트나 종교 의식 같은 것들이 발달을 하게 됩니다. 여기 보시면은 길을 이렇게 딱 가서 비행기 활주로처럼 만들어 놓고 양쪽에는 활주로에 있는 그 라이트 같은 것들을 횃불로 저렇게 표현을 해놨죠. 그리고 짚을 엮어서 만든 비행기도 있고 왼쪽 소녀는 그 비행기 조종사들이 쓰는 고글 나무로 막 엮어서 이렇게 만들어 놓습니다. 그래서 이 사람들은 이런 것들을 해놓고 의식을 이렇게 계속 진행하다 보면은 하늘에서 다시 비행기가 나타나서 우리에게 좋은 것들을 나눠줄 것이다라는 믿음으로 이런 일도 계속 진행을 하는 거죠. 그래서 저희들이 그럼 이 원주민들에게 무슨 말을 해줄 수 있을까요? 뭐 비행기 색깔이 조금 이상한데 검은색으로 바꿔본다던가, 뭐 곡을 지금 나무가 너무 두꺼우니까 너무 얇게 좀 바꿔본다던가, 이런 피상적인 것들을 계산하는 것으로는 이 근본적인 문제를 해결할 수 없다는 겁니다. 그래서 저희들은 이 문제를 다룰 때 항상 이런 마인드셋을 가지고 저희 이더파이에서 프로덕트를 만들고 있습니다. 그래서 동일한 이러한 논리를 크립토로 가져오면은 가장 이 근본이 되는 게 무엇인가를 저희들이 생각해봤을 때 항상 누구나 말하는 탈중앙화, 그걸 이제 다시 한번 강조하는 하나의 이야기로 말씀을 드렸습니다. 그래서 이제 카고 컬트 크립토라고 이제 보면은 이제 저희 이더리움은 상대적으로 탈중앙화가 돼 있는 반면에 바이낸스 체인이나 솔라나 같은 것들은 이 일부의 노드 운영자들에게 굉장히 중앙화가 되어 있는 체인이죠. 물론 바이낸스 스마트 체인도 장점들이 있다라고 혹시 말을 하고 싶으면은 예를 들면 트랜잭션 코스트를 낮추고 스케일링 솔루션들을 뭐 도입을 한다던가 이런 대중화에 기여를 했다고 말을 할 수도 있습니다. 하지만 저희가 봤을 때는 이것은 전혀 크립토 아니다. 뭔가 탈중화가 빠진 것은 이 피상적인 뭐 스마트 컨트랙이라든가 코인이라든가 이런 것들을 생산하는 피상적인 것에 목적을 둔 거지 이거는 크립토가 아니라고 주장을 하고 싶은 겁니다. 그럼 이제 저희 이더리움은 어떤지를 조금 더 살펴보면 보시는 차트는 이 이더리움 검증 노드들이 사용하고 있는 인터넷 서비스 제공자들의 분포입니다. 전 세계 이더리움 노드의 65%가 아마존에서 운영이 되고 있고요. 그리고 2위는 이제 헤츠너라는 독일의 이제 인터넷 서비스 제공 회사인데 10%가 넘습니다. 적지 않은 비율입니다. 근데 헤츠너 같은 경우는 이제 작년 말에 솔라나 노드가 갑자기 뭐 중단이 된다는 이런 뉴스들이 많이 돌았는데 그때 헤츠너가 바로 그 솔라나 노드들을 갑자기 중단시켜버린 그 그룹입니다. 그래서 이더리움도 항상 그 리스크에 노출돼 있다라는 점을 말씀드리고 왜 아마존이 저렇게 큰가를 보시면 이제 전 세계에서 이더리움 노드들의 분포를 보겠습니다. 거의 50% 가량이 미국에 있는데 미국을 조금 더 들여다보면 그 중에 50%는 그 버지니아주에 있는 애쉬번에 위치를 하고 있고요. 근데 이 위치를 자세히 들여다보면은 저기 워싱턴이 있는데 이 조 바이든 대통령이 있는 백악관에서 한 20마일 정도 떨어지고 뭐 CIA 헤드쿼터에서 20마일밖에 안 떨어져 있어서 뭐 물론 그 위치라는 건 상징적인 거지만 굉장히 중앙화가 많이 돼 있다라는 것을 보실 수 있고요. 그리고 두 번째는 왜 이런 노드들이 저 한 데이터 센터에 다 모여 있는가에 대해서 질문을 해야 됩니다. 그래서 그 중에 가장 큰 요인은 이 노드들이 서로 같은 지역에 뭉쳐서 서로 네트워크 커뮤니케이션을 빠르게 함으로써 어떤 트랜잭션들을 서로 들었는지를 교환하고 그 정보를 이용해서 수익을 얻는 일종의 MEV라고 하는 수익을 극대화하기 위한 방법으로서 노드들이 모두 이제 모여든다고 생각하시면 됩니다. 그래서 이제 저희들이 원하는 것은 저런 정말 근본적으로 비행기인 탈중앙화된 프로토콜이지 이런 뭔가를 모사하는 형태가 아니다라는 점을 말씀드리면서 저희가 시작한 지 얼마 안 된 회사인데 이제 저희 회사에서 어떤 것들을 하는지 한번 설명을 드리겠습니다. 그래서 예상하셨다시피 저희들은 탈중앙화된 스테이킹 서비스에 집중하는 이더파이입니다. 그래서 저희들의 이제 서비스를 구성하는 다양한 요소들을 보면 첫 번째는 계속 강조드렸던 펀드의 주인이 되는 스테이커들이 키를 모두 유지할 수 있는 형태를 만드는 게 저희 목표고요. 그리고 그런 탈중앙화된 노드들이 전 세계에 이제 퍼져 있을 때 그 위에서만 구현될 수 있는 특별한 서비스들이 있을 겁니다. 그래서 그런 서비스들을 컴포즈할 수 있는 형태로 저희들 API라든가 이런 걸 개방하는 게 목표고요. 그리고 세 번째는 그런 식으로 이 탈중앙화 네트워크에 헌신해서 기여했던 스테이커와 노드 오퍼레이터들이 그 위에서 만들어진 서비스들에서 발생하는 레비뉴를 쉐어 받을 수 있는 파이프라인을 만드는 게 목표입니다. 그리고 네 번째는 라이더나 로켓풀처럼 리퀴드 스테이킹 데리버티브 토큰을 발행해서 디파이에 이제 다양하게 쓰일 수 있도록 하는 게 4번에 해당합니다. 그래서 이제 저희 이더파이에서 이제 어떤 식으로 스테이킹이 일어나는지 이제 간단히 복잡해 보이지만 간단히 설명드리면은 이제 노드 운영자들은 자금이 없는 상태로 혹은 부족한 상태로 그렇지만 노드를 운영을 하면서 얻는 소득은 최대화하고 싶은 사람들입니다. 그래서 그런 사람들이 저희 이제 옥션 메커니즘을 이용해서 내가 검증 노드를 하나를 운영하고 싶기 위해서 비딩을 하게 됩니다. 특정 금액을 걸고. 그럼 이제 스테이커들은 그 중에 가장 높은 비딩을 한 노드 검증자와 노드 운영자와 매칭이 되고 자신이 직접 본인의 윗줄 키와 밸리더 키를 생성한 후에 이를 노드 운영자들에게 넘겨주게 됩니다. 근데 이 과정에서 노드 운영자들 즉 본인이 매칭된 노드 운영자만이 본인의 밸리더 키를 가지고 운영을 할 수 있도록 노드 운영자의 퍼블릭 키로 인크립션을 해서 전송을 하게 되고요. 그럼 밸리더 키는 해당 키를 디크립트해서 노드를 운영하게 됩니다. 그래서 이런 형태에서는 노드 오퍼레이터가 가진 것은 밸리더 키밖에 없기 때문에 노드 운영만 할 수 있고 그리고 스테이커는 윗줄 키를 컨트롤하기 때문에 그 돈 자금이 들어오는 것을 직접 컨트롤하게 되고요. 그리고 밸리더 키를 갖고 있기 때문에 본인이 이 자금을 언제든 엑시트하고 회수해야 된다고 판단을 한다면은 항상 본인이 이를 직접 엑스큐션 할 수가 있습니다. 그리고 이제 다음은 저희가 작전명 솔로 스테이커라고 부르는 오퍼레이션 솔로 스테이커로 저희들이 다양한 회사들과 파트너십을 맺어서 지금 시작을 하고 있는 프로젝트입니다. 그래서 간단히 설명을 드리면은 저희들이 이제 전 세계에 다양한 탈중화된 스테이커 분들을 많이 모셨는데 슬로건이 뭐냐면은 왼쪽에 보시는 저게 이제 작은 PC입니다. 노드를 운영을 위한 PC고 저 노드 운영을 위한 PC를 무료로 얻고 패시브 인컴을 얻을 수 있도록 저희들이 지금 판을 한번 짜보고 있는데 우선 댐 노드나 아바도에서 저는 1차형 PC를 한 달에 한 $30 정도면 구매를 할 수 있습니다. 할부를 해서. 그리고 오볼이라는 데서는 분산 검증 기술이라고 해서 노드가 하나의 검증 노드의 역할만 하는 것이 아니라 그걸 또 한 레이어 더 검증 절차를 올려서 더 약간 폴트 톨러런트하게 만드는 그런 메커니즘인데 거기서 기술 지원을 받고요. 그리고 이더파이 저희들은 그 운영자 솔로 스테이커가 운영할 밸리더 키를 생성해서 이를 넘겨주고 솔로 스테이커는 이 노드를 할부를 이용해서 구입한 기계로 본인 집에서 직접 운영을 함으로써 할부도 갚고 익스트라 캐시플로우도 좀 나오는 형태의 모델을 이제 짜고 있습니다. 그래서 저희들이 이제 세계에서 이제 다양한 솔로 스테이커 분들을 모시기 위해서 이렇게 트위터에 글도 올리고 했는데 우리 400명 이상 분들 그리고 75개국에서 이제 다양하게 오셨고 그 중에 저희들이 첫 번째 배치로는 12명의 솔로 스테이커 분들을 모셨습니다. 이제 보시면 이제 위치가 굉장히 다양한데 뭐 홍콩, 코스타리카, 뭐 과테말라, 밴쿠버 이런 데도 있고 그 직업들도 굉장히 다양하십니다. 뭐 첫 번째는 이더리움 맥시멀리스트, 굉장히 이 이더리움 탈중앙화에 기여하겠다는 마음이 가득하신 분. 뭐 두 번째는 교육 쪽에 있으신 분. 그리고 뭐 트위터를 쓰시는 분, 뭐 실제로 테크니션이신 분도 있고. 그래서 요분 같은 경우는 예를 들면은 32 이더리움이 없지만 나는 스테이크를 하고 뭐 탈중앙화된 이것에 기여를 하고 싶기 때문에 참여를 했다라는 분도 계시고요. 그리고 또 굉장히 다양한 형태를 봤는데 저희들이 이제 테크 쪽에 아무래도 종사하시는 분들이 굉장히 많았습니다. 그래서 저희들이 바라는 것은 이런 분들이 이제 탈중화된 네트워크에 계속 참여할 수 있도록 도우면서 이 전체 모델이 이제 서스테이너블하다는 것을 보이는데 이 프로젝트에 이제 목표가 있다고 볼 수 있겠습니다. 그래서 이렇게 탈중화된 네트워크를 직접 빌드함으로써 그 위에 더 많은 서비스, 더 의미 있는 서비스를 만들고 그로부터 레비뉴를 만들어서 이게 지속 가능하다는 것을 보일 텐데 그래서 저희가 믿는 것은 탈중화를 통해서 이게 이더리움 커뮤니티 좋을 뿐만 아니라 이것이 프로핏으로도 이어질 수 있다라는 것을 보여드리고 싶습니다. 그래서 대표적인 예가 이제 최근에 핫했던 에이겐 레이어라는 게 있는데, 에이겐 레이어는 이제 이런 분산된 노드들을 이용해서 어떤 앱들의 뭐 보안을 강화하는 형태를 말합니다. 근데 아까처럼 이제 아마존처럼 이렇게 센트럴라이즈된 곳에 모여 있는 노드들로 뭔가를 시큐리티를 강화한다 이런다는 거는 말이 안 되고요. 그래서 저희들은 탈중앙화를 네트워크를 구축함으로써 이를 달성할 수 있다고 보고 있습니다. 그리고 그렇게 구축된 네트워크 상에서 저희가 블록체인 데이터 서비스나 RPC 서비스 등도 구현을 할 수 있는데, 이로부터 나오는 레비뉴들은 모두 스테이커와 노드 운영자분들에게 공유를 해드리는 형태로 모델을 만들고 있습니다. 그 다음 이제 좀 펀 프로젝트로 저희가 진행하고 있는 NFT 프로젝트가 있는데, 다들 이제 NFT라는 것은 어떤 약간 갬블링처럼 해서 이렇게 얼마를 주고 뽑아서 뽑기처럼 해서 좋은 게 나오면 돈 버는 거고, 일단은 비싼 걸로 이렇게 많이 생각을 하시는데, 저희들은 이 NFT를 스테이킹이랑 결부를 시켜서 NFT를 소유한다는 게 스테이킹을 했다는 것과 동일해서 NFT를 가짐으로써 패시브 인컴이 들어오는, 그러면서도 굉장히 쿨한 픽처들이 NFT에 연동되도록 한번 만들어 보고 있습니다. 그래서 이더팬이라는 프로젝트를 저희가 런칭을 하고 있는데, 이 이더팬을 통해서 민팅을 하는 행위가 바로 스테이킹을 하는 거고요. 그래서 그렇게 스테이크된 이더리움들은 저희가 앞서 설명드렸던 그 탈중앙 네트워크를 위한 솔로 스테이커와 노드 운영자들을 위한 이제 노드를 런칭하는데 쓰일 거고, 그래서 저희들과 스테이킹을 해서 더 오래 계실수록 멤버십 포인트가 올라간다던가, 그리고 스테이킹 리워즈가 어떤 형태로 부스팅이 돼서 더 많은 스테이킹 리워즈를 받으신다던가, 이런 것들이 이제 가능해지게 됩니다. 그리고 저희가 기획하고 있는 것도 굉장히 이런 이더리움 커뮤니티에 도움이 될 수 있는 이벤트 같은 것도 기획하고 있고, 이 NFT를 통해서 참여하실 수 있도록 한번 만들어 보고 있습니다. 그래서 처음에 이제 조인을 하시면은 브론즈 티어에서 시작을 하시는데, 저희와 함께 스테이킹을 오래 하실수록 뭐 실버, 골드, 플래티넘, 그 후에는 이제 더 추가되는 형태로 이 멤버십 프로그램이 만들어져 있고요. 그래서 저희들이 바라는 형태는 이런 식으로 이더리움의 탈중앙 네트워크에 내가 기여했다라는 것을 저희들이 이제 자부심을 가지고 사용할 수 있는 하나의 프로덕트가 되면 좋겠다라는 마음으로 프로젝트를 진행하고 있습니다. 이건 이제 저희 내부적으로 이제 NFT 이미지를 어떻게 할 거냐, 이거를 그냥 장난삼아서 이제 많이 얘기를 해본 건데, 예를 들면 이제 스테이크니까 저기 이더리움 스테이크가 있고, 이건 이제 저희 대표 마이크가 좋아하던 이제 저희는 이제 이더리움 네트워크들의 수호자 같은 포지션을 가지고 있으니까 이더리움 장군들 이렇게 해서 했는데, 여기 이제 NFT 관계자분들이 많이 계실 것 같은데, 혹시 이런 컨셉과 어울리는 뭐 아트가 있으시면은 연락을 주시면 이제 좋을 것 같습니다. 그래서 저희가 믿는 것은 이때까지 이제 탈중앙화 이 모두가 말했는데, 이게 언제 중요해지냐면 이제 중요해질 때까지, 예를 들면 FTX가 무너지기 전까지 그게 중요했던 것처럼, 그래서 이런 생각을 가지고 저희들은 계속 프로덕트를 개발을 하고 있습니다. 네, 제 발표는 여기까지였고, 혹시 질문 있으시면 질문을 받고, 아니면 조금 더 일찍 자리를 비워드리겠습니다. 맞습니다.
All right, next up we have Kalos Hachi Labs. They'll be doing a talk on opinionated survey of ZKP security.
시간은 그냥 충분히 쓰겠습니다. 어차피 빨리 시작했으니까. Okay, so apparently we're starting a little bit early. It's only 1:50, so I'm just gonna take my time and try to like speak about as many things as I possibly can. But anyways, so the talk today will be about ZKP security. I am Kyumin Ro. My nickname is RKM0959. I'm currently head of security. Head of security researcher manager at an audit firm called Kalos. We have been recently exploring with the new hot topic of the blockchain world, which is ZKP. So we're doing some ZKP audits. We are currently good friends with Zelic and trying to cook up some ZKP auditing with them. So from my recent experiences, I have cooked up some surveys and got myself some opinions about how we should view the ZKP security world. So in this talk, I'll try to talk to you about how I think about how I view the ZKP security world and what we can learn from our previous audits and security-related lessons. Okay, so the story begins with my opinions on how the ZKP development cycle works. So basically, when you develop something, you will first have a rough idea about what exactly you are going to build. So you're going to start with some, at least quote-unquote, documentation about what your application will look like, how it will behave, what's the input and what's the output, and how the state will change, and stuff like that. So from there, you will change your written documentation into code, obviously. So to do that, you will figure out what exactly you need to check. So for example, I want to build this AMM or something like that, and to build such AMM, I need to check this, I need to check this, I need to check this. So if I check if A, B, C are true, then the AMM works correctly, so everybody's happy. So if you finish that kind of process, you will end up with a list of raw constraints to check. So from there, you will, since this is ZKP, you will spend some time trying to arithmetize that list of raw constraints into a ZKP circuit. So by implementing your ZKP circuit, you will take those raw constraints and turn it into a ZKP arithmetization. And alongside that, since you need to generate proofs and stuff like that, you will also have witness generating logic. So that is the third stage, so the ZKP arithmetization and the witness generation. And from there, you will apply whatever system you are trying to apply. For example, it could be just Planck over a BN254 curve. So you apply those cryptographical magic, and somehow, some way, we will end up with the final prover and the verifier logic. So there are 3 or 4 steps regarding the development cycle, depending on how you look at it. And the main point I'll be trying to make is that each of those 3 or 4 steps are, there might be some vulnerabilities that are attached to one of these steps. So for example, what kind of vulnerabilities could happen in the specification part of the development cycle? So for example, if you're developing an AMM, you might want to check that your specifications actually make sense. So for example, this is true in literally every software development cycle, I might imagine. If you're developing an AMM, regardless of whether you're just doing it raw in Solidity or doing it in a ZKP-like way, you might want to check that the AMM specifications make sense. So for example, if I'm a user and I swap 100 USDC for some Ethereum and then sell those Ethereum for USDC immediately afterwards, if I have more than 100 USDC, then something is obviously wrong. So you might want to perform a sanity check of your app design before you do anything, and that's the 0th part, the specifications. And now we get to the second part, the step 1, which is what you have to check. So just a reminder. So now that we are done with the specifications, now we move on to the list of raw constraints. So basically, here you end up with, to make this application, I need to check A, B, C, and D. And now there's now I'll show you this table. The top row shows whether a specific test case input matches the specs or does not matches the specs. And on the left side, we have whether the test case input passes the list of checks you described or fails the list of checks you described. So the obvious incorrect cases are, the first one is the over-constraining, where the inputs does match the specifications, but fails the list of checks you described. In this case, it means that you got worried too much, and you added too much checks, and now the list of, now that the things that should obviously work fails. So for example, you're writing an ERC20, and apparently like, I have 1,000 USDC, and I try to send some person 500 USDC. It obviously should work because I have more than 500 USDC, but somehow, some way, the ERC20 developers got too worried and added a bunch of unnecessary checks, and somehow I can't send my USDC. That's obviously a big issue. And while in ZKP security, usually the more emphasized mistake between the under constraints and over constraints is the under constraints, but because it happens much more, But at the same time, we should not take the over constraints very lightly. It's clear that, for example, if you're over constraining stuff, some stuff that actually should pass does not pass, then it could definitely lead to some issues like, for example, denial of service and other issues of that sort. And those are definitely not the type of vulnerabilities to take lightly. So one point I'm trying to make here is that over-constraining is, while it is not very intuitive, it is still a very important class to take note of. And the second one is relatively simple. It's the under-constrained one, where the inputs that does not match the specs actually pass the checks. So you need to add more checks into your list of checks to do. And this is also obviously very important. Like, for example, if there's a under constraints in the ZK-VM, then maybe you could like push 6 bytes even though the opcode is push 5 and something like that. So the point being, from the first 3, oh, and also another point I will try to make here, because we have a lot of time, is that while usually in ZKP security, when we're talking about under constraints, it usually discusses the mistakes in the arithmetization side, but sometimes under constraints can happen by just like forgetting a check. For example, like in Solidity security, in smart contract security, obviously there are like quote unquote novel attack vectors like reentrancy and stuff like that, but at the same time, a good chunk of bugs, vulnerabilities come from just business mistakes. So like forgetting a check, like forgetting how the business logic should work and stuff like that. So here, for example, on the just simply forgetting a check thing, if your ZKP application deals with elliptic curves, as a lot of the applications do, like for example, if you're doing like BLS 12381 curves and BLS signing and stuff like that, you will definitely deal with elliptic curves while writing a ZKP circuit. And if you are dealing with those stuff, you might want to check if you're reviewed that your circuits deal point doubling correctly, because the formula is different from the case where you're adding 2 different points. Also, in that case, maybe your circuits are not dealing with the point at infinity incorrectly, and you might want to check that. And these two issues are like not ZKP, does not come from the ZKP thing. It comes from the elliptic curve and how to deal with things. So point being, not all under constraints bugs are like truly, their essence does not come from the ZKP side. Their essence comes from like the actual application side. So point being, from the first 2 steps is that the security fundamentals are still very relevant. Even though like ZKP security is this really like unexplored, relatively unexplored, mysterious landscape, it's still security. So the stuff you learn from basic security principles still carry over to this new world of ZKP security. So for example, the resolution from this is basically you need to check whether your application design actually makes sense. And this is true in literally every software in the world, not just ZKP software. And these parts pretty much says that you need to make sure that your list of test case inputs are very good. Like it covers a lot of different parts and stuff like that. Its coverage is very good and stuff like that. And this is true in pretty much every single software development, not just ZKP. So yeah, the conclusion from the first two steps is that the security fundamentals from other areas are still very much relevant in the ZKP world. So now the main fun part of the ZKP world, ZKP security world, is the circuit implementation. The bulk of ZKP-specific vulnerabilities or mistakes come from this side, where you take the raw constraints and somehow, some way, arithmetize it to your choice of the ZKP. So this list comes from the ZK bug tracker repository on GitHub by 0xPark and Kyle at Ethereum Foundation. And it lists some common vulnerability types. And these are really the main dish of the ZKP security. So I'll just read them out real quick. So under constrained circuits, non-deterministic circuits, overflows and underflows, bit length issues, unused public inputs that are optimized out, frozen heart vulnerability, trusted set of leaks, and the discrepancy between assignments and constraints. Okay, so from here, the idea that I had that I would like to share with you is this. So if you look at the list and take these 4 vulnerability classes, so overflows, underflows, range check issues, and bit length issues, and if you look at these vulnerability classes and think deeply why these vulnerability classes are possible, the conclusion that I had is that these issues, these vulnerability classes are possible because our proof system, for example, BN254 Plonk, deals the whole arithmetization thing over a 254-bit prime field. So since we are dealing everything over a prime field, and not something that we are used to dealing with, like the set of integers or something like that, because of this we deal with the prime field kind of thing, we have to be careful about overflows because prime field wraps around P. We have to be careful about range checks because obviously everything wraps around P. There's nothing such as negative integers in a prime field and stuff like that. So point is, from a vulnerability class, we can think about it and deduce what part of this arithmetization tactic leads to this kind of a vulnerability. So what we can do thinking in reverse, what we can do if we want to create new types of bug classes, new types of bugs, is that we can start from the nature of the arithmetization tactic, and then from there we think about how this part of the, for example, if we're dealing with Plonk, what part of Plonk could lead to a vulnerability? So let's think in this way and think about what kind of vulnerability classes that we can think about. So one part of Plonk that is very important and used prominently in ZKP circuits is the use of a lookup table. So lookup tables obviously used a lot these days to improve performance and stuff like that. And one issue that was recently found is the dynamic lookup table issues. So basically what happened is that the usage of dynamic lookups is very tricky, and sometimes the developer can make a mistake and it could lead to a soundness bug because of a quote-unquote evil row in the dynamic lookup table. So to briefly explain, usually the lookup table is fixed column, usually, but sometimes you actually need for performance to use a lookup with an advised column. And what could happen is that, for example, if there's 3 rows here, what could happen is that the first two rows are constrained properly, so they have no issues whatsoever. But the third row is not constrained at all. So what we can do, what a malicious prover can do to use this to their profit, is to maliciously change this unconstrained third row, and then use that malicious value to look up things. So the lookup argument is still verified, but since this third value is designed maliciously, they can do whatever they want and possibly even break the protocol. So that's what happened, and this kind of shows that if you think about lookups and think deeply about how lookups could break stuff, then we could see this bug class and think about think that, oh, this is derived from the nature of Plonk that we use, which is that we use lookup arguments. Okay, so and another thing that is used prominently in ZKP circuits is selectors. And there are various ways where selectors being used improperly could lead to a vulnerability. So one is the selector enabling logic being flawed. And the second is the misuse of selectors that aren't actually fixed columns. So we'll showcase the two with some examples. The first example is from the Scroll's Poseidon circuit. So we recently audited Scroll and found this interesting bug. So what happened is that this is from the Poseidon hash table, and what happens is that they begin with filling the first one or two custom rows, and it returns the offset to begin the main hash table body rows. So you see that filling the custom rows returns the offset, and then the offset is used as an argument for the hash table body function. And the number of custom rows, 1 or 2, is determined based on whether this Boolean value NPT only is true or not. And what happened was, in the case where NPT only is true, they return 1 as the offset. So in other words, the main hash table body rows is started at offset 1, but at the same time they enable this this selector called scustom. The scustom is basically a selector which denotes whether this row is a custom row or not. So they made a mistake of enabling this custom this selector at offset 1. So in reality, these two logics should have been swapped at their positions. And it also happens so that there was a gate created that if the scustom is turned on, i.e. it's a custom row, then the hash inputs and control value, the control value is the remaining amounts of bytes to be hashed, are forced to be equal to 0. So what happened in conclusion is that since the first row of the hash table body is mistakenly set as a custom row, the first inputs, the first hash inputs and the first control value is mistakenly over-constrained to be equal to 0. So this breaks the entire hash table, which is pretty bad. And another thing, the second part where we discussed this one. Yeah, the misuse of selectors that aren't actually fixed columns. So here, so sometimes we select the constraints based on expressions over a prime field or columns that aren't actually a fixed column. So for example, if we want to select a constraint based on some value being 0 or non-zero, then we could we could calculate the is0 chip and then take the is0 expression and then use it as a quote-unquote selector for a gate. And in some rare cases, selectors are actually just defined as advice columns. So you have to prove that it is constrained properly to act as a selector. So for example, this is the Poseidon hash circuit from the ZK EVM at PSC or Scroll. And you see that this S-sponge continue thing is obviously a selector. It's named like a selector, but it's a column advice. So it's an advice column, not a fixed column, but it still acts like a selector. So we actually spent some good amount of time proving that this S-sponge continue is properly constrained to act as a selector for this specific logic. And another point about selectors is that sometimes it doesn't really matter if the selector values are Boolean. For example, if I'm using a selector Q to denote that if Q is turned on, then this expression is forced to be 0, then usually the developers will write it in the form of Q times expression is equal to 0. In this case, all that is important to force that expression is equal to 0 is the fact that Q is non-zero. So Q doesn't have to be exactly 1 to force that the expression is 0. Q can be 5, Q can be 6, Q can be 7. It can be anything except 0 to force that this expression is 0. So in this case, even though Q is not Boolean, everything is fine. You just need to check that if Q is turned on, then Q is non-zero. That's the only important thing. However, this isn't the only case where selectors are used. One other case that is definitely possible is you are using a selector with a lookup argument. And this is the case that gets interesting. For example, if you are claiming that this Q times expression is inside a table T, let's just say fixed table, a fixed table T, there are two things that you need to be concerned about. The first thing is that since if Q is 0, this should be immediately true because the lookup arguments are turned off. It should be immediately true, and that means that 0 should be inside this table. And you need to check that 0 being inside this table doesn't break your protocol. You can mangle with the table to deal with this issue. The another thing is that if the lookup argument is turned on, you might want to check that this Q thing is actually 1. So for example, if Q times expression is inside T and Q is non-zero, that is not enough to force that this expression value is inside T. Because if Q is 2, for example, that means 2 times expression is inside the table, not expression. So you might want to check that this Q value is actually Boolean. You need to constrain it properly to make sure that your lookup argument isn't flawed. So for example, to quote-unquote prove that this is actually a possible attack vector, I'll show you a close call. This wasn't a full vulnerability, but this was a close call in the ZK EVM. So for example, in the bytecode circuit, the ZK EVM checks that this tuple of opcode and push size is valid by utilizing a lookup table. So basically, push 5 corresponds to 5, push 10 corresponds to 10, and so on. And for this lookup argument, the selector was an AND, a multiplication of 3 things. I'll show you with the code, but one is the fixed column of fixed selector of Q enable, a fixed column selector Q last, which should be turned off, and finally the tag of the row, which is expected to be 1 for byte and 0 for header. So here we have the code. So basically, the enable is an AND, a multiplication of these 3 things, and the third is byte thing is the tag, and this enable thing is used here, to force the lookup argument to actually happen when enable is turned on. And the problem here was that the issue was, not issue, but the main idea was that this tag value, which is derived from the is byte meta part of the code, is actually an advice column. So it can be anything it wants. And at the same time, it was never actually directly constrained to be a Boolean value. So what we could do here is that since this is byte thing is not necessarily Boolean, that means that the enable value is not necessarily Boolean either. So what we could actually do is, since push 5 is opcode 0x64, which is 100, and push 5 obviously pushes 5 bytes, this 100, 100,5 is actually inside the lookup table. And this means that we can actually put tag to equal 5, opcode to equal 20, and push size to equal 1. So since 5 times 20 is 100 and 5 times 1 is 5, this actually passes the lookup argument. But at the same time, it's very clear that 20, as in opcode, does not equal push 1. So this is actually a flaw. You know, the opcode and push sizes are not matched correctly. But thankfully, there were some like other checks going around, so like this wasn't a full bug. But anyways, this was a pretty cool idea. And the conclusion being that with a ZKP backend and the arithmetization tactic, we can think about how certain properties of the tactic, for example, the usage of prime field, the usage of selectors, the usage of lookups, and so on, can lead to vulnerabilities. So this could be an interesting way to deep dive into certain bug classes, how to divide the taxonomy of the bug classes. And certainly, the more bug classes we have, it will be more fruitful for developers, security researchers, auditors, and maybe even tooling builders. So this is one way to think about the taxonomy. And there's the final part, which is the cryptographical magic. And there are two subsections in this final cryptography section of the vulnerabilities. One is that the backend cryptographical magic part is just implemented incorrectly. And one is the developer is misusing the framework. For example, in the forward part, we could say that the trusted set of leak is on this side because it's not dealing with the toxic waste, quote unquote toxic waste properly. Or for example, if you're talking about frozen heart, it means that your backend is not dealing with Fiat Shamir heuristic correctly, and so on. And a special case here is the optimized out public inputs. This is dealing with the gross 16, gross 16. And the reason that this is in between these two things is that this vulnerability class can be handled on the back end, but also can be handled on the developer side. So, for example, this optimized out public inputs thing can be handled on the back end. For example, Snark.js has some dummy constraints to stop this whole optimized out public inputs thing, and now the developers don't really have to worry about it anymore. But at the same time, the developers can just by themselves add these dummy constraints so that they don't have to worry about this issue anymore. So it's interesting. So this kind of bugs can be handled on the back end by the actual tooling developers, or it can be handled on the developer side who actually uses those toolings. So point being, the conclusion being that so since the optimized out public inputs thing is a very very not easy nature of gross 16, we should think more about like the new ZKP techniques in this security-focused way. So for example, recent few years in ZKP research have brought out very cool tactics and technology. For example, there's like snark aggregation, recursive snarks, there's starks, there's like bunch of polynomial commitments. There are a bunch of new arithmetization tactics, and there's like folding schemes. There's like a lot of very cool developments going on. But at the same time, we haven't really started to pulling these into our development cycle. We haven't really thought that much about the secure usage of these tactics, these technologies. So my claim is that we might want to start the study on secure usage of these ZKP techniques, and it will be a very interesting topic. And the solution for these new discoveries on potential vulnerabilities might be in the backend / tooling side, but it might be also on the developer side, or maybe it's just both. So vulnerability classes that are similar to the relation between gross 16 and the public inputs being optimized out. This technology and vulnerability mapping should be an interesting topic for study in folding scheme and some type of vulnerability or something like that. So it'll be very cool to think about this, and that's the point. So we have covered all 4 steps of the ZKP development quote-unquote cycle, and discussed how each part can lead to a potential vulnerability class. So that's the talk, and I would like to thank Kyle for the ZK bug tracker, and some nice discussions prior to making this presentation. 0x Park and their security group, which has taught me a lot of things, and Scroll for allowing me to share some findings here and allowing me to, me and the friends at Zelic to audit their circuits. It's been an honor, and you can contact me at my personal email or my work email or whatever. So thank you.
All right, next up we have Merrick from Cello. He'll be doing a talk on scaling on and off ramps with Fiat Connect.
Awesome. Everyone, my name is Marek Olszewski, and for those of you who don't know me, I'm one of the co-founders of Cello. And today we're going to be talking about Fiat Connect and how it's helping us scale on and off ramps. If you don't know me, you can find me on Twitter at Marek_. I have a really long last name, and so I tried to make it really easy for you guys, and I just replaced it with underscore. But anyway, yeah, I wanted to start with a question for you. I wanted to see how many of you here are using crypto for payments on a regular basis. How many people are buying their coffees, paying for taxis, buying anything online? Any hands in the air? Is there anybody here who's, oh, Shinju's got her hand up. We got one over here in the front. I frequently do use crypto as well. Anybody else? Oh, two more over there. So we have 4 people out of, I don't know, 50 people who use crypto regularly for payments. And I don't know about you, but that makes me sad. And I think it also probably makes Satoshi sad, shown here in the form of a very sad cat emoji. Because crypto, right from the get-go, was supposed to be all about payments, right? Like the original Bitcoin white paper talked a lot about payments. I think a lot of folks in the Ethereum ecosystem talk about ETH being money and being useful for payments. And yet, here we are, 4 people only raise their hands. And so why do you guys think that is? Any ideas? Anyone want to wager a guess? Anybody who didn't raise their hand, what do you think? Yes, over there in the back. Merchants are afraid to accept crypto. That is a good reason. And I think there's certainly some truth to that. Any other guesses? Yeah. On and off ramps are expensive. That is another good guess. And I think also a true statement. And I think if we go back in time a little bit, the reasons that folks were giving were a little different, right? Like I think in the past, we used to always hear, oh, blockchains are not scalable enough, right? Like we just don't have enough block space for payments. And luckily, that is no longer a reason, right? Like it can't be that blockchains are not scalable enough. We also heard back in the day, before USDC, before Tether, that crypto wasn't good for payments because it was volatile, right? But luckily we have stable coins now, so stable coins are no longer a reason, so it can't be that. Address derived addresses were also commonly talked about as being a really bad UX for normies. But now we have a whole bunch of new identity systems, right? We have ENS, we have on Cello, you can actually send money to phone numbers, you can register your phone number with an address. So it's no longer these identity systems. In the past, people said it was just too hard, right? Wallets were difficult to use. They weren't as easy to use as they are now. And I would argue that wallets have gotten good enough now. And so it can't be that wallets aren't good enough now. And this is maybe a good opportunity for me to do a quick plug for a company that I work for, Valora, which is a really easy to use mobile wallet. If you are curious about a really easy to use mobile wallet where you can send value to phone numbers and pay for gas with tokens, definitely check out Valora. You can see here in the back that the two primary actions that we encourage people to perform is actually send and request. So it's really focused on this payment use case. Cool. So why is it then? I think we got a lot of really good guesses, and I think I generally agree with both of those. And I think maybe to summarize it, I think ultimately one of the issues is it's just too hard to cash in and out, right? Like the fees are too high. For merchants, it's too difficult, so that makes them wary of accepting it. And I think ultimately the issue is one around cash in, cash out. If we can make it easier to cash in and out, then we can be in this transition period where we're working towards this infrastructure inversion, which will ultimately flip payments to be done on public blockchains instead of in the traditional financial rails. A lot of people are excited for that future. They're predicting that future. But to get there, we need to be in this transition period. And to do that, we need to make cashing in and out much easier. And I think it's important for us to solve this because this is the future that we want, right? Raise your hand if this is the future that you want. All these people rushing to your dApps, to the house of Web3. Yes, I want this future too. It's an exciting future, right? Like this is what we're building towards. But sadly, this is not what we have today. This is what we have. The 4 people who raised their hand earlier, we get to have all the fun. But all our normie friends, all of the folks who aren't using crypto right now on a day-to-day basis, they're, not having this fun. And that looks like fun. I don't know about you. Cool. So, and you might be saying, well, cashing in and out, it's possible. You can use exchanges. Why do you need something better? And I would argue that, for most normies, if you want to get to that crowd, this crowd is not going to be using exchanges. And I would also argue that that crowd is probably also not going to be using on and off ramps that are integrated into wallets and dApps the way that the Transacts and the Ramps and the MoonPays and the Wire type on and off ramps are currently integrated. These are all really great services. I'm actually a really big fan of them, but they tend to be services that look distinct from the actual wallets and the actual dApps that people are using. They tend to require an extra login. They're probably too complicated for your typical normie friends to really be able to kind of cash in and out of their wallets really easily. So I think we need something better. And so the question is, what do we need? Well, I would argue that we want native on and off ramping in every wallet, in every country in the world, right? Like, let's imagine that in every wallet that you have, in your pocket, on your phone, you can connect that to a bank account easily with a native experience without going through a web view, without using an iframe, without having to create an account on a third party. You just connect your bank account to your wallet, and you can on and off ramp, and that experience exists in every country in the world, right? I think we can all agree that if we can accomplish this, that would be something that would be pretty exciting for Web3. And not only would it be great for Web3 and dApps, but it would also be like incredible for just sending payments around the world, right? We could live in a world where you could send money to anyone, right? We kind of already live in that world, right? You can send crypto to anyone in the world. They can custody it with a self-custodial wallet. But the thing that's missing right now is this immediately available for use piece, right? Like, you can send money to everyone in the world knowing that will be immediately available to use. If we can solve this, that's going to have a profound impact on, I think, society, on the world, certainly on Web3. And if you think about it, right, like we used to live in a world where you couldn't send a free text message to anyone in the world. And now, like thinking back to a time when, pre-WhatsApp, it's kind of strange, right? Like now it's just so obvious that you can communicate with everyone in the world instantly on their phone for free. And it wasn't that long ago and that wasn't possible. And so the same will happen with payments, but to get there, we need to make that value be immediately useful. And for that, we need on and off ramps. So how do we get there? Well, if you're a wallet, maybe you integrate with a ton of on and off ramps, right? Like everywhere, on and off ramp, integrate, go. 1, 2, 3, 4. Valora's been doing this. We've integrated with 12 on and off ramps plus. Usually these are bespoke APIs with these WebView experiences. Every market that there's a new on and off ramp, we go out, we try to integrate it. And we're not the only ones, right? I'm sure you've seen your wallet of choice has an on and off ramp, maybe even multiple on and off ramps that they've integrated with. Everyone is integrating with everyone. And this takes real effort. And if we want to get to that future where we have this available in every country in the world, then there's a lot of countries in the world. That could potentially mean hundreds of integrations, right? Because to offer a great experience, you want to integrate with an on and off ramp that has certainly the local licenses, but also the local connection to local financial rails, right? So you can actually cash in and out for cheap, so you're not wiring money across borders. That can be expensive. That means that you'll be integrating with very local on and off ramps in every country in the world. There's going to be many of those on and off ramps. And integrating with many, many, many on and off ramps, I don't know about you, but when I talk to my engineers, that is generally not what gets them excited to wake up every morning and get to work, right? Integrations, maintenance, hundreds of these things. Generally, that makes them grumpy. And so we want to do away with grumpy engineers. Obviously, we want to make things simple. And so how do we solve this? Well, coming back to this diagram, the answer might be pretty obvious, right? Like there's this many-to-many spaghetti mess in the middle, right? Like, can we simplify that? Can we make this much easier? And the answer is absolutely. Let's put something in the middle that everything communicates through. That is one way that we could, solve this. Let's move to a hub and spoke model. And so Fiat Connect, as you've probably guessed by now, is the hub in this hub and spoke model. It sits there nicely in the middle. It really is designed to solve this problem and to help us get to this world where you'll be able to send value to anyone in the world and they'll be able to immediately be able to use it. And so what concretely is Fiat Connect? The way that I like to explain it to people is it's kind of like the Wallet Connect of on and off ramping. It's designed to connect wallets and dApps with these hundreds and hundreds of on and off ramps that are going to be coming online and are already coming online around the world. It's API based. So the wallet and the dApp itself gets to control the UX 100%. And so it's a backend API, and if you think you have the best design for on and off ramping, then you're welcome to implement it, and then you can use Fiat Connect on the back end to actually execute the caching in and the caching out. But you don't have to rely on others to build these experiences, and you can have one experience that is the same for everyone, regardless of where they are around the world. And critically, once you've integrated this once, adding a new on and off ramp becomes just a configuration change. There was a comment about how on and off ramping is expensive. One way to make it cheaper is to get more competition. To create more competition, we want to make it easier for people to integrate new on and off ramps that are coming to the market. And so Fiat Connect can help with that. I mentioned already that this allows wallets to have full control over the UX. Fiat Connect also supports, it has all of the compliance support that you would need and expect. On and off ramping is obviously a very highly regulated service that these on and off ramp companies provide, and so compliance is very important. So Fiat Connect supports letting the wallet or the dApp collect the identity information of the user, maybe do a liveness check, and then with the user's permission, share with the on and off ramp so they can do the compliance screening that they have to do. And critically, it enables you to do this once, and then you can share your data with multiple of these on and off ramps as you're using them, so you don't have to keep collecting your KYC, you don't have to keep scanning your face, uploading your driver's license. You do that once, and then the wallet can share that again with all of the different on and off ramps that you might want to use. And so that's a really nice UX win. So if you're interested, if you're a developer and you want to hear more, learn more about Fiat Connect, definitely check out fiatconnect.org. That's the website for the open source project. It is an open source project. There's no company behind it. And so you can also check out the GitHub for it, which is linked to from this website. And normally this would be the end of my talk, but there's only one problem with that. And I think that's really well demonstrated by this slide. Who's seen this slide before? It's an XKCD slide. So there's a problem with standards, right? Like lots of people are very opinionated on how things should work. And people say, oh, this is broken, we need to fix it, let's create a new standard. And then they do, and then suddenly we have one more way of having to do something. And instead of actually solving the problem, we've just made it more complicated. And this is a real problem that we want to overcome. And so we've been working really hard to form a Schelling point around Fiat Connect to really make it the standard that everyone adopts. And so hopefully you can help me go and evangelize Fiat Connect and make it the standard. I think otherwise we're just going to have a more complicated time integrating on and off ramps with one more way of doing so, ultimately preventing us from getting to kind of that world with that big crowd of people coming in that we're all working towards. In addition to all of us in this room going out there and helping make this to be the standard, the Celo Foundation launched Connect the World, which is a public goods funding competition. It was launched last year with $20 million of incentives. And so the idea is that folks would compete to become the first on and off ramp in any market out there, any country out there, to launch their service with Fiat Connect support. And if you are the first, then you get a slice of this $20 million. And that's been really great. That's incentivized a lot of on and off ramps to go out there and start launching in various markets. And I'm super happy to share that Fiat Connect is now live and implemented by a number of wallets and on and off ramps. Just earlier this year, Valora celebrated the launch of 3 markets, Nigeria, Kenya, and the Philippines. That was really exciting. And so in those markets at the time, you could actually on and off ramp with a native experience in the wallet in those markets. So you wouldn't have to leave the app. You wouldn't have to create a new account anywhere. It was just a pure native experience. And since then, 9 more markets have come online, which is pretty cool. And so Fiat Connect is now live in 10 markets throughout Africa, and then India and the Philippines as well. And so this is where we are now, which is a pretty great start. But as you can see, there's a lot of gray still. But luckily, this competition is spurring a lot of companies to launch their on and off ramps. And so we're seeing more and more on ramps coming online. And this is what the map will look like hopefully very, very soon, if I were to guess based on kind of all the activity that I'm seeing out there. So that is pretty cool. And this is now live, and so it has real users. And when you have real users, you can actually get quotes from those users. And so we went out there and we started talking to people and asking them what they thought of the experience that they now have within Valora. And we got some pretty good ones. So Philip from Ghana was pretty stoked that they could cash out to their mobile money account. So Fiat Connect supports multiple schemas, not just transferring to a bank account, but in countries where mobile money is popular, you can connect your mobile money account with your wallet. And so Philip is able now to cash out directly into mobile money in Ghana, which he really, really enjoyed. Rachel in Kenya was previously using a P2P exchange. Those are pretty common in a lot of markets, but she was very happy to be able to cash out without having to go and trust some third party to facilitate one of these P2P exchanges. And so she was pretty stoked by that. And then Emmanuel had what I think is probably one of the best quotes that we received. It's really, really profound. So let me know what you think. He said, Fiat Connect is very, very okay. And I think that's profound because when you think about it, on and off ramping should just work. It's not rocket science. It doesn't have to be complicated. It shouldn't require a lot of steps. It should just be reliable and work and ultimately just be something that's in the background that is ultimately very, very okay. And so we were really stoked to see this quote. We think we ultimately did a good job given the sentiment. We also got a quote from an engineer, which I think you guys might appreciate. So when Valora added Ghana to their list of markets that supported Fiat Connect on and off ramping, they needed to make a one-line change in a configuration file. It was very easy to do that. And that made our engineers very happy. They were not grumpy cats. And this was quite something that the team really celebrated. So we were pretty excited about this. So just to wrap up, what's I think cool about Fiat Connect is, we're really one step closer to this kind of vision that we were talking about earlier. Not only will we hopefully soon be able to live in that world that we talked about, you already live in a world where you can send money really easily to anyone in those 12 countries that I talked about, knowing that they can really easily cash those funds out and have it be immediately useful. And so we're chiseling away at this problem, and hopefully we'll get there soon so that this is possible for everyone in the world. And more so than just for P2P payments and remittances, one thing that makes me personally really excited about when it comes to making on and off ramping really, really easy is, naturally there's been a lot of talk after FTX, reminded us just how important self-custody is and how important, the fact, not my keys, not my crypto, really is. It's a reminder that, we want to move to a world where you don't have to trust institutions with your money. We want to enable exchanges that are really easy to use, but ultimately can be performed with full self-custody. And obviously we have DEXs today, but the main blocker for DEXs is cashing in and out into these applications. And so if we have a way to cash in and out in every country in the world, into stablecoins. And maybe if we also add stablecoins for every currency in the world, and then like on Celo, if you can pay for gas with these stablecoins, Celo supports paying for gas with tokens, then you can create an experience where people are cashing into their wallet and then using a DEX to buy whatever crypto they want and hodl whatever crypto they want without ever having to give up their keys, without ever having to give custody of their funds to a third party. They can do it all with an experience that looks and feels like a centralized exchange, but that is fully self-custodial. And so I don't know about you, but I'm very excited for this future where we can enable these types of applications. And I think Fiat Connect will help us get there. So thank you very much.
All right, next up we have Dell from Block Native. She'll be doing a talk on MEV and block building, a deep dive and a look at what's to come.
Hello. Okay. Hi, everyone. My name is Delane, and I'm from Block Native. Today, I'll be sharing with you guys about MEV and block building, a deep dive on that, and a look at what's to come. But before we begin, Block Native, what do, right? The funny thing is that I had conversations with some people here, and they were wondering what Block Native was. So I think this will give you a really clear view about it. So Block Native, we've actually been running pretty robust infrastructure and set of tools for giving users access to the pre-chain layer and also to transact with confidence since 2018. And what that looks like is, a lot of people many dApps would be familiar with our wallet integration and, real-time notification tool called Web3 Onboard. We also have gas fee prediction, transaction simulation, mempool, Explorer, and APIs. And a lot of our tools are available as, APIs, SDKs, and webhooks. So we are a real infrastructure project. And if you were here on day one and you attended the Matt from Proximity Labs talk where he talked about blockchain OS, you would have heard that he mentioned using Web3 Onboard as that wallet integration tool. And Proximity Labs is not alone. If you look at NPM, we actually have over 9,000 weekly downloads of our core package for our Web3 Onboard, and that is super Saiyan cool. So we've taken that expertise in running infrastructure and expertise in mempool to this new frontier of block building. And we are now we've actually stood up our block builder since the merge, and we currently deliver about 5 to 7% of the network's blocks. And not only that, we are currently running 1 out of the 10 active relays on the network. So we've really taken a step further into Ethereum's core infrastructure. So for today, I'll talk about 3 main narratives about, firstly, why MEV matters and how MEV is created, how PBS is impacting the MEV market, and finally, share the MEV and more. So I know maybe a lot of you would have heard about MEV floating around this term, or you've been hearing about it over the past couple of months. For those who are unfamiliar with MEV, I'd like to give you a definition for the sake of this presentation. So MEV, I would define it as value derived from explicit manipulation of transaction ordering. And MEV is really interesting and important at 2 levels. Firstly, I talk about the block level, and secondly, the user transaction level. So at the block level, so why does MEV matter at the block level? Primarily because a block value is computed based on these 3 elements: transaction fees, MEV, and issuance. So let's talk about issuance first. So before the merge, when you build a block, you get a pretty significant sum of ETH issuance because the network has to pay for the power required to build those blocks. After the merge, that is no longer the case, and therefore the issuance actually dropped significantly. So this is where that ultrasound money meme came from, or that triple halvening, of issuance. So as you can see here, therefore, with the reduction in issuance and in the network, the transaction fees and MEV, or rather the impact, the influence of that at the block level has greatly increased. Then we can also look at the daily average percentage of MEV transactions in the block. If you look at this chart over here, you can see that overall the trend is going up and to the right. So MEV transactions, on average, is showing up more in our blocks. If you look at daily gas and MEV revenue, with the orange bar being MEV and the blue bar being gas fees, you can see that it's not just the daily average of MEV that's increasing. You can also see that in certain events, and this post-merge, after the merge, by the way, you can see that in certain events, the MEV revenue really spikes up, and with some days of MEV revenue even accounting for multiple days. So that's pretty wild and a very interesting development. So overall, the relative economic influence of MEV has really increased post-merge. So why does MEV matter, right? Just at the block level? Because the source of MEV is actually you and me. What do I mean? So MEV comes from transactions, and it comes specifically from end user transactions. So how does that work? So let's take a look at transactions in the mempool, or the place where transactions live before they get on chain. So over here, you can see that in this representative mempool, these transactions have different gas fees. And in naive ordering of a block, you get these transactions that are ordered from top to bottom based on the amount of gas fees that they have in that transaction. And there's no MEV here yet, it's just naive ordering. So this gets really interesting when you look at, let's say, an arbitrage example. So if we look at transaction D over here, where what transaction D is doing here in this situation is that it's moving the price on an exchange. And as a result of that, there's a price differential between two exchanges. And what this means is that it sets up an opportunity for an actor to come in and insert a transaction to neutralize or balance that difference. Normalize prices and earn some ETH as a result of their work done. So it gets complicated when you have more than one arbitrager or one actor that is trying to do so. And what happens is that there's this competition where they start to submit multiple transactions just to get into that position right behind transaction D. And as a result of that, you used to get gas wash, which is a real problem for the network. And that's no longer the case because, over time, there's this new solution which is called MEV bundles, proposed by the MEV Research Consortium Flashbots to help mitigate the negative externalities of MEV opportunities in this way. So MEV bundles, what happens here is that instead of just spamming the network, these actors or these MEV searchers, they send bundles to block builders, where in these bundles, they specify that, okay, I want to have my transaction come after transaction D in this bundle, and the block builders will execute that. And as a result of that bundle, there's, let's say, an opportunity or potential revenue of $100, and it's shared with the block builder. So there's a revenue sharing situation in this ecosystem, and from that extracted value of ordering. So arbitrage is just one example. So there are different types of ordering with different types of outcomes. There's displacement or front running. There's insertion and sandwich, where you have a MEV transaction that is in front and behind the target transaction. So if you have done a Uniswap transaction, and if you are sandwiched, you have less favorable settlement. There's also suppression or censorship, where you have these multiple transactions that come in before the target transaction, and as a result, the target transaction gets pushed out of the block or does not get included in the block. So this happens during major NFT drops, where it's just wild, right? And in fact, what's interesting is earlier when I shared with you that that slide on the MEV, outsized MEV revenue, that was an NFT drop event. So I know MEV sounds pretty, it's pretty uncomfortable, but it's actually everywhere. So MEV exists in all ordered transaction systems. So in the case of search engines, we all know that your search result 1 is better than search result 10, right? Because of visibility, because of click rate. And we are all pretty comfortable with the idea of search engine optimization, where essentially you manipulate search engine ranking, search engine indexing to get better ranking for your search result. And in search engines, concert ticketing, air traffic control, equities trading, there's MEV. Right? It's just that in Web3, it's open and we can see it. And this feels uncomfortable at first, but in the long run, this creates opportunity for a better systems design, precisely because we can see what is happening and we can do something about it. So a step towards better systems design is proposer-builder separation. But before we talk about proposer-builder separation, we need to first understand how block building works and how block building works, essentially. So blocks are the foundation of a blockchain, we know that, and blocks are made out of transactions that are ordered, assigned a hash, and put into a block. And those who are building blocks are considered core infrastructure, like block native. Pre-merge, the mining pool operators were the ones that built the block. They built the block, and they also proposed the blocks to the network. But there was a problem with this. And the problem was that just 4 to 5 entities had the power to do so in the entire network, and this created centralizing effects where they decided the block template of the blocks and the blocks that actually land on chain. And an extension of that problem was that there was evidence of manipulation at this level, where there were offshore agreements and preferential treatment, and these entities often they were offshore, so it was hard to perform checks and balances on them, and this ultimately went against the values of Web3. So with proposer builder separation, a fundamental change in the network happened, and I'll highlight 2 things. The first one is the role of the block builder was separated from the proposer, and now we have a new separate class of actors called block builders that build only. Then we have the role of the proposer that was adopted or combined with the validators, and I'm sure everyone knows what a validator is, so that's what happened. So under PBS, the validator can still get their blocks built locally, but few entities would have enough resources to meaningfully do this in an efficient way, right? There are essentially 3 things that you need to do very well, right? Validate, build, and propose. And not just build, but you want to build really high value, juicy blocks. So it's really hard to do that. The alternative is that they could outsource that block construction to block builders like us. And this is completely opt-in, and it's via this sidecar called MEV Boost that was created by Flashbots. And right now, where we are at, this is proto PBS. And the end goal, of course, is to get to enshrine PBS, but a lot of research is still being done about how we're going to do that sensibly. So how is PBS actually performing so far since the merge? If you look at mevboost.org, this is last week's data. You can check it, it's 24 hours. So 89.4% network participation is, so 89.4% of blocks are currently done through MFBoost. And if you look at the cumulative slot share since the merge, before the merge happened, there was like around 20% of slot share that the relays had. And up to now, we have now up to 80%. So what this means is that validators are opting to outsource their blocks to block builders. and for good reason, because the average block value over vanilla blocks is up 4.41x. So this is huge, right? And that's why that's the incentive. And if you look at this table over here, under the second line, average transactions included, for non-MEV blocks, the number of average transactions included is 143, while the MEV blocks have about, on average, 153 transactions. So what does this mean? So this means that third-party block builders are a lot more efficient in terms of including value in blocks, in sharing that value with validators, and using block space in a very optimized manner. And a large part of that value, as I shared earlier, is MEV. So who gets the value derived from MEV? So here's the situation today. So today, MEV value flows away from the transaction originators like you and I that create these MEV opportunities to the searchers and the validators. And that's because the users don't have the power to express their preferences to the network. So that's the situation right now. But we think there's a better way to approach this, that, is there a way for that value to flow back to end users? And block builders are in that position to do so because we are able to programmably express what happens at the block, right? So, and then specify what happens in the block and therefore potentially create value flows or that have that value flow back to the users. So block builders are in that pole position to create new opportunities with MEV through these programmable, expressive, fluid value flows. And block building is just really the tip of that iceberg. We block builders are here to help with MEV and create a more equitable ecosystem. But a lot of that specialization, that source of compute network is also applicable to 4337 account abstraction in the form of running bundlers. So in fact, Block Native is currently also running a bundler on Gurley, and we're coming soon to Polygon Mumbai as well. And after account extraction, there's 4844 proto-dank sharding, where this same specialization could also come in to support activities like data availability sampling. So if you heard in Igor's talk yesterday, that's what he was talking about. And as more and more specialized actors with great sources of compute and abilities come in, you start to unlock a lot of very exciting features, such as guest sponsorships, pre-confirmation, and in the future, ePBS will take place, and so much more. So that was the block building and block building's future, but what about MEV itself? And right now, there are a couple of options being discussed around where MEV is headed, and a lot of it is still in the research and discussion phase, but out of these things, these are the three conversation paths that are happening. First one is MEV sharing, which is an example of what I shared earlier about recirculating that value back to users and creating alternate flows through order flow auctions. There's MEV burning, where you burn the MEV and you get consistent, what you reap is the consistent consensus and execution rewards. And this is also something that was mentioned yesterday in another talk as well from Nethermind's team. And finally, MEV smoothing, where you reduce MEV variance through validator pools. So that is just where we are at right now, and it's so exciting. So what can you do with this knowledge? It feels a little bit far away, esoteric even, but here's what you can do. For those who are running ETH validators, or if you're connected to a validator pool, connect to Block Native's Dreamboat MEV Boost Relay and optimize your staking rewards. Because if you're not, you're leaving about 5 to 7% of the blocks on the table in the network. For searchers, if you can send your MEV bundles to our endpoint, that's also one thing that you can do. And for devs and builders, know that this is what it's about, what is ahead, and check out Block Native's MEV and 4337 technologies and content. And for anything else that you would like to talk about, happy to continue our conversation offline or off stage. You can find me at Telegram, DFTDMM, and on Twitter at DelaneSays. So thank you.
All right, so we are done with talks for now. I have an announcement for the hackers. Please pitch your projects now according to the tracks you selected. If you participated in the general track, the near track, proximity, or mass network, please go to the mentor room, which is also called the moon room, and it's like over there. And if you participated in the graph, Filecoin, or WorldCoin, please go to the booth area and pitch them. You must pitch by 3:30 p.m. for us to select the top 12 to pitch in the main room. And please don't go anywhere until the closing ceremony. Hackers are welcome to sign up for the after party. The event link is in Discord, so please sign up if you're coming. All right, thank you.